Hello, this is my Advent of Code 2024. My name is Nawa Man. I'm the author of FunctionalJ.io. I would like to use Advent of Code to highlight the ability of FunctionalJ.io, which bring functional programming goodies to Java. Today is day 2. In day 2, we will distract a bit from searching for the chief historian by helping analyze the result of the red nose modular reactor. The unusual data consists of one report per line here, and each report has number of levels separated by space. In this example, the data contain 5 levels of report. In order to determine that the report is safe, the levels of these have to either all increasing or all decreasing. And the decrease or increase should be in between 1 to 3. So in this example, the first report is safe because it all go down from 7. And for this one, it's unsafe because it go up more than 3. This one is unsafe because it go down more than 3. This one is unsafe because it go up, go down, and then go up again. This one is unsafe because there are levels that are the same. And this one is safe because it keep going up. So in this case, there are 2 safe reports. Now let's see the code. So we are on day 2. Let's get me explaining about the code a little bit. So the code is organized into multiple days. I'm actually on day 9, ready for day 10. The code is organized into actually a test and not a program. And that way, when I know the result from the example, I can put the result example here. And then I write the code here. When I run the test and I see that example turn green, let's see here, then I know that whatever the result of the production data is correct. Then I get the result here. So let's remove this for now. Then I will see that the example is green and the test production is blue. In this case, it's not equal. Then I can see that the result is 411, and I put this 411 as the answer. Let's see this page. So it's here. It's here. 411 is the answer. So this way, I can quickly reiterate my code and then keep running it until the first one is green. Then I know what the result of the actual data. Okay, another thing we'd like to talk about is that the data actually saved in this folder. So that's the data and data 2. So the example of part 1, which is the same as the question here. Okay, and then that is an actual data, which are much larger and more messy. So you will be able to get the data, in the bottom here. Okay, so when you click on it, it will open a page that you can copy and paste your data. There are some way to automate that, but I'm not there yet. Okay, so let's get back to the code. As I mentioned last time, there are some functions that I made to make this easier because we always need to do something like this. Like regx is a function to create a regx pattern object. Grab is a function to apply this regx into the line and then create the result as a function list of string that capture that parts in. Okay, maybe you can go in there, and it's use string functions, which is part of functional J. So you can actually use this, but I want to make it even faster. And then There are many more of these functions as I go along, and it's useful. I put it here. Sometimes I put it as a function instant, like parse int, like this, so that you can easily parse the value from string into an integer, primitive integer. There are also this function, read all line, which will examine the function that called it. In this case, if it run from test example, it will open up example files. It knows that it's a day 2 part 1, so it will open day 2 part 1 example and then parts into line, get that, and then call a report. So this way I don't need to worry about where the data came from and make a mistake. It figured that out reflectively. You can see the code here. I don't know why it's set up that way, but yeah, we can it can figure things out this way. Oh, it's like here in the challenge kind and challenge name and stuff. Just in case you are interested. Okay, so now let's see the problem. What's the problem again? Okay, let's see the problem again. So we have multiple report, one report per one line, and each report has different levels. And in order for a report to say that it's safe, the level have to either go all increasing, all decreasing, or all decreasing, and the decrease or increase should be between 1 and 3 inclusively. Sorry, it's 3. Okay, now we recap the question. Let's go to see my answer. By the way, I solved this live, and then I refactor the hell out of it so that it reflects what we're going to use in production, right? In production code, you make it work. The first time it might look ugly, it might not be performance, and then you refactor it. So this is the refactor code. I go through it number of times as I learn more about this, and I refactor code so that it look kind of cleaner. So we want to calculate the saved report, the number of saved report. So from all the lines, I look through it one line at a time to extract the report. So you can put this one in there directly, or you can extract it out. So I want to show that it depends. If you want this to be more descriptive, instead of having to read the code, you can just put it in a method like this. So what does it do to extract the report? So it just grab a regular expression of 0 to 9 from the lines. The result is a functional list of string, and then we map each element into int using parts int. The result is the integer functional list. I usually use the explicit capture group like this rather than \d, I think, in Java, because I don't remember those. Different language have different code for that. Sometimes it's the same, sometimes it's different. So I usually prefer explicit. Okay, so that's enough for extracting reports. So this only extract one line, right? One report. So the result of this is multiple reports. Then we'll filter a report that is safe. After we get the saved report, we just return the size of it. So that is the number of the saved report. So how do we define the saved report? In this case, we get the report, which is the functional list of integer. Then I calculate the diff between the two. We see the sign of it. Okay, at this point, you may wonder, what the hell is this? So let's visualize this. So I print out what is the diff. Okay, it might be hard to see. So let's also print out the report itself. Okay. It run both production data too. So in this report, you can see that when we calculate the map 2, which means map of windows of 2 elements, and then the first one will be A, the second one will be B, and then I do A subtract B. So in this case, A subtract B, I get 1, and this A subtract B, I get 2. This is A subtract B, I get 2. This A subtract B, I get 2. So that is the different array, different list of this report we do for all of them. And as you notice, when the level go down constantly, all the diff will be plus. And if the report, the levels go up, the diff will always, all of them will be minus. If it go up and down, the diff will be plus sometime and minus sometime. If it stay, it will be 0. You can also see that for some of the change, it go beyond 3. Like in this case, a different is 4 and different is 5. So by calculating the diff, you can easily detect all those conditions of being safe. But first, we need to, because keep going up and keep going down have no difference. So it's best to normalize the direction. So in this case, I just get the first element and see if it's less than 0, then the sign is -1, otherwise it's 1. And then for all the diff, if there is none of them, that the sign times the diff, right? So if it's negative, it will flip it to the diff to the plus. So in this case, it will be 1, 5, 1, 1 rather than -1, -5, -1, -1. And then if the sign times diff is less than 0, less than equal to 0, or greater than 3, that means this is not safe. The condition is not safe. So if the diff value have no condition that is not safe, so non-match, the not safe condition, then you report that is safe. I realize that this is not as clear. So unsafe condition. Sorry, wrong one. Okay, again, you can see that it's not about writing the shortest code possible, right? You see I said that this is short code, but it's not about writing the short code possible. It is about representing your thought as close as possible without going too much, too much noise, or too cramped, and then you lose your intention. So in this case, this thing, unless you go take a look at it in detail, you may not know the details, right? You may not realize what that is, but by giving it a name, then it can easily realize. I'll further adjust this. For the unsigned diff. Okay, so we check the condition, and then for the unsigned diff, this is the condition. So to sum up, for each line, we extract the report, which is just grab all the number for each line, change it to ints. And then for each of these report, we check if it's safe. And we do that by doing the windowing of the number. In this case, we only want 2 number. And then we calculate the difference. We normalize the sign. We can also do this. Okay, so then we just do this. Or you can also do this as well. Okay, again, whatever you want to do, whatever fit your way of thinking, you can do it. In other words, functional J, because of being functional, right? It allows you to write decorative code. You can adjust how much or how less amount of code you want it to see from that. Okay, so that's what the result is, and when we run it, we get the result equal to 2. That's what the question say right here is 2. Alrighty. So that is for day 2, part 1. Now come day 2, part 2. For part 2, it said that the engineers are surprised that the number of safe report are so low, just only 2 out of 6. So they reread the rule, I guess, and then they found that if there is only one bad level in the report, it's considered to be safe. So in this case, this 2 was not safe earlier, but if we remove this level number 3, this report becomes safe because it goes from 1, 2, 4, 5. And if we remove this 4, this report becomes safe because it goes from 8, 4, and no repeat, right? 6 to 4, and then go to 1. So by calculating the safe this way, we can get 4 reports as safe. So how do we do it? There might be an algorithmic way to calculate that. I try and end up with that timing. So we can do brute force. Basically, try to remove each of the number from the report and see if the result is safe. So let's see the code. Okay. So for part 2, okay, let's compare to part 1. Let's move to part 1 here. You can see that there are a lot of similarity as function count instead of count safe report in part 1. Now it become count kind of safe reports, which as you can see do very similar things. But instead of is safe report, it now is kind of safe report. Extract report are the same, and then actually the is safe report are also the same. I refactor it. I like to keep them similar. But instead of call is safe report, we call the is kind of safe report, which basically perform this safe check to the report directly. And if it doesn't work, well, make mistake again. If it doesn't work or it is not safe, then we go from 0 to the size, and when we and then we exclude that element. So exclude at is the exclusion at the element I. So we exclude the value of that index. So we do it from 0 to the size, so all of them basically one at a time. Once we remove it and we see if the report is safe. Again, as you can see that the code very reminiscent of the way we were thinking. It expresses what we want to say quite straightforwardly. If you do this in an iterative form, you might get the smaller code, but because of the noise and what you intended to do might merge, them might hide in it rather than express it like this kind of save and save or remove one and save, that sort of thing. Okay, so that's it. Again, this is Advent of Code 2024 Day 2. I'm Noah Man. Thank you so much for watching.